and share my screen. And so today I'm got my web browser opened to a topic 4 folder in our class repo here. And I have a bunch of quick announcements before getting into technical-ish stuff for today. First one, just timeline about how we're doing. Right now, we're about a week behind how previous versions of this course have been running. The main reason for that is we've just been doing a little bit more stuff with Bash and Git and Lambda server background. So I'm happy with sort of the pace that we're on, still a good pace. Probably this Friday, it'll be another lecture normal class. And again, one of the reasons that we have the 3 classes per week is because I have the baby at the end of the semester coming at some unknown time. And so this will, getting us the lecturers on the Fridays occasionally, will make sure that we have enough class time when I take the 2-week break when the baby comes. For the assignments, I've decided that I will extend the deadline for the Flask on Docker most recent homework assignment. Nominally, it was due this past Tuesday, but I'll give you until this coming Sunday to keep working on it if you would like to do it. No problems with submitting it earlier, though. Along with that, I've graded everybody's Lab 2 Docker. I was happy with what everybody had, so everybody got 4 out of 4. I chose not to apply any late penalties to that. And I want to emphasize, though, despite these sort of like extensions, your next homework assignment is posted. We'll start talking about it today. And I really promise for real this time that there will be no extensions on that assignment, that I want us to make sure that we stay on track here timeline-wise. And so that one definitely will be due a week from tomorrow. Good thing about where we're at in this class right now, so we're doing a transition from all the Docker containers, a little bit of Bash and Git at the beginning, to new material now on SQL. And the stuff based on SQL will depend on all the stuff that we've been talking about so far in order to bring up the databases and get us our working environment. But there's not going to be any new like Docker stuff, not going to be any more like weirdness where you have to spend hours fighting stupid error messages in Docker. It'll all be fighting error messages in SQL from this point out. But the good thing about that is that like the errors will be much more straightforward and not the weird random errors where everybody's getting all sorts of different things because of whatever the ghosts in the computer are deciding to make go wrong with your code. Quick outline of what to expect from the rest of the class. So the rest of the semester. The next about 3 weeks or so, we'll be going over how to make SQL commands that are correct. And I'm going to go like from the basics of SQL all the way to some pretty, what I would consider intermediate things, but relatively advanced things. And so there's not really like SQL background that's required, but there is a SQL prerequisite for this course, especially the data science major people coming in should all have some SQL, and that'll make this coming section go a lot more smoothly if you've seen some SQL before. But if you haven't, then it'll just mean a little bit more work fully understanding the SQL stuff. We'll have about 3 weeks of that again, and then a midterm exam. On the midterm, it will only include stuff from the next like 3 weeks portion of this course on the SQL, and it will not include anything about Docker or Bash or Git or those things. The main reason why we're not going to include like all this Docker stuff is because, as you've seen, the Docker program is so finicky, and the midterm, I don't want it to be like testing your, I don't know, ability to debug all of these weird dependency hell sort of issues. It's important that you've seen that to be able to run the stuff for the midterm, but the midterm is going to be focused only on the SQL stuff. After the next 3 weeks, getting the SQL commands correct, so writing SQL queries that are going to correctly give us the data that we want them, the answers that we want. We're going to spend the rest of the semester, 6-ish weeks or so, about how to make those SQL commands and other things that we're working with really fast. And in particular, like our big motivating goal is we'll want to be able to do something like have an interactive web page where we're searching, say how Instagram does, many petabytes of data, and search through that in just milliseconds in order to satisfy user queries in real time. Any yes?
What's the format of the midterm?
Question is, what's the format of the midterm? Good question. The answer is that we'll see here in a little bit what the format of the homeworks are going to be. And the midterm will have the exact same format as the homeworks. It'll be a take-home exam. You'll have probably, you'll have at least 48 hours to work on it, maybe more. And the difference between the homeworks and the midterm will be just weighting in terms of the midterm will be worth a little bit more points. And the homeworks, you'll have the collaboration opportunities, but you won't for the midterm. For people who took the data mining class with me, this midterm, most people find to be much more straightforward, easier than the data mining grades tend to be really good on this midterm. Yeah, one of the reasons they're good is because you'll have your laptop Lambda server connection with you, and you can exactly run all the queries and make sure that you're happy with what the answer is before submitting it. Good question. Any other administrative sort of questions? Oh. Question is quiz this Wednesday. Pretty sure I gave you, yes, it's on the glob things that I talked about last week. So it's like the star operator and the weird security sort of problems that go along with that. So we'll have that quiz this Wednesday. And we'll continue having more quizzes throughout the remainder of the semester. Some of them will be on SQL. Some of them will be coming back to the Git and the Bash stuff. But the Git and Bash not on the midterm, just SQL stuff on the midterm. Yes. Midterm will be take home. I don't have a set date for us. It'll be approximately 4 weeks from now. So yeah, apologize that the dates and scheduling and stuff for this class is all a little bit up in the air because of the paternity leave stuff. But I promise you'll have enough advanced warning to be prepared for that. Good questions. Any other questions about administrative stuff? Okay. I want us to do maybe like 5 or 10 minutes of review stuff on Docker, of the Flask on Docker system, some more of the weirdness that maybe we didn't fully talk about last time before we get into the new SQL material for day. And then once we get into the SQL material, it'll probably be, we'll go through this notes today. It'll probably be a relatively less technical day. First thing, I've got some links open here. I don't think I pulled up this graph ever in class. I just wanted I wanted you all to make sure you'd seen it at least once about Docker adoption growing significantly. This company, Datadog HQ, is just like a cloud service provider, and they're showing how many of their clients are using Docker. This graph ends in 2018. But the growth has still been continuing. And so many companies using Docker these days. And again, one of the main advantages of Docker is that you're not tied down to like AWS or Microsoft Azure or any cloud provider, that you can just easily switch between whichever service is offering the lowest rates. And so especially on like these these sort of cloud providers. They're much, much cheaper than AWS. So people like switching over using Docker. Question?
Was it invented in 2014? Is that why it grew so much then? Or was
Yeah, question is, why did it start right here? And the answer is, yeah, this idea of containers was first invented in 2014. And so that's when people started adopting it. Google, forget the exact year that Google started using containers internally, but that was another like big uptick in Docker usage. And like all the major FANG companies these days are using Docker exclusively internally. Just one other thing to pull up here. I pulled up the Instagram tech blog earlier. Netflix is also known for having a really good tech blog. So by 2017, Netflix had switched over all their internal stuff to using Docker. And if you're interested in reading about that, then this link is provided on the topic 3 folder as well. Yes, question. So you have the homework that used to be due tomorrow. You're welcome. I encourage you to still submit it tomorrow, but it won't be considered late until Sunday, and then there will be a new homework due next Tuesday. Yeah. There will be no lab for this week. I want to quickly jump to the issues for a second. Highlight in this issue right here, something that's very common for students to do is to take screenshots of text and post those into issues. And I want to encourage you all to get out of the habit of posting screenshots. If you do this on like a real world repository, everybody's just going to ignore you and not bother responding to your questions, because Google and search engines can't go into the screenshots and figure out what all the text is here. And so they can spend a whole lot of time working with you to debug things, but then Google will never find this when somebody else is searching for the same problem. So instead of posting screenshots, just actually like copy and paste everything into a code block, and then that'll make everybody much happier, much more likely to want to answer your questions. This issue over here as well, we're going to I'm going to come to the terminal here in a second, and we'll take a look at this issue in detail. The overall formatting of this issue is great. Anytime we're posting problems with Docker, though, one thing that we should always include is the output of the logs command showing the Docker logs, because if there's any error messages, this is where this will display the error messages, and so always include that output. We're going to go take a look now in the Flask on Docker, and I just want to illustrate exactly what goes into those log messages. And I think there's going to be a lot of people who are maybe stuck on the database not having the right things inside of it. And so by doing this, we'll see how to debug that. And this will take maybe 5 minutes or so for us to do. The first thing I want, let's see, so I can run Docker PS. We can see there's nothing running right here. If I do Docker compose up -d right here, bring the system up, you can see everything got brought up here. There's no error messages being displayed. We get this deprecation warning up here, but this is just a warning. It's not going to actually affect anything. And then everything seems like it's working down here. If I run the in order to connect to the database, I'm going to .env.dev like this. This URL right here is a common way for connecting to a database that normally in URLs you've seen like HTTP or HTTPS to the left of the colon. Having Postgres to the left of the colon means that it'll be a database that we're connecting to. And down here, if I do something like Docker compose exec DB, DB because that's the name of the service, and then run pSQL, and then pass this as the flag to pSQL and hit enter. Then I'll be connected to the database down here. And if I do the \t like this, oops, that's not it. \d, we can see that it did not find any relations down here. Those of you who have seen SQL before, a relation is just the fancy word for a table, which you can think of just like as an Excel spreadsheet page. There are no, and all information in a database is stored inside of these tables or relations. And so there is no relations inside of here. So the question is, why is Postgres not able to find any of these relations? I'm going to scroll up here and have one more comment about this right here, that the tutorial doesn't give a command that looks anything like this anywhere. Instead of passing the full URL to the pSQL command, it has you pass some different flags to the pSQL command. It does the exact same thing. This is just a more general tool for connecting to a database. You can pass the URL like this and change the parameters in the URL to specify whatever you want. But now, so why exactly is there no relations in this database? Up top, I'm going to leave vim:\q, and we'll start by running Docker PS. Always, like, the first thing you should do anytime you're debugging anything related to Docker, run Docker PS and figure out what's going on here. And here I can see that there's only one actual service running. And if I look at the docker compose.yaml file, there are two services here, web and DB. The DB service is running, this one right here, the Postgres, but there is no, I can see it called DB right down here. Again, for the name, it's the folder that you're in, and then the name of the service. I can see there's the DB service, but there is no web service. The web service is the thing that's responsible for actually creating the users table inside of here. And so if I want to see like what went wrong with the web service, I can run docker compose logs and then web to get the logs for the web service. And looking through here, I can see that I have some errors in my Python file, this manage.py on line 9. I'm going to come out of my pSQL session down here, open up services/web/manage.py. Again, I strongly encourage you, once you're inside of a project, never use the cd command again. Always maintain the project root as your working directory. And we open up manage.py, 9gg, go to line 9, and we can see that there is this invalid Python code right here saying barf and error. And this caused this, this error message up here, barf and error. Barfing in Python is the technical name for what happens when there's something like a syntax error or any error message, and Python displays that error. We say that Python barfed an error message out. So here, this is invalid Python code, so that's causing an error. I'll just delete that, dd:, save down here. Anytime I'm editing my Python files, again, I have to docker compose build all of the services. It'll rebuild that, rebuild the image, and now I can do docker compose up-d. The thing that I can, one thing that I can do to check what's going on, run docker ps. Again, a good debugging tool. Just make sure that now we do in fact have two services running. We do in fact have two services running, so that seems good. I could go ahead, I could also rerun the logs on the web, check to see if there's any error messages. I don't see any error messages here now. I just see that I'm actually connected up here. And so now down here, I will rerun that pSQL command. I pressed Control-R, typed in pSQL to get back to that command down here. And now if I type in \d like this, now I can see that that web service did in fact recreate these tables. That's the 99% most likely cause of these tables not being created is the web service having an error inside of it. Probably a more subtle one than the error that I had there, but that's how you go about fixing it, is you always look at the logs for the service that did not come up, and that will tell you what the error messages are for that particular service. Fix those errors, and then that service will do what it's supposed to do. Any questions about that? Okay. One last thing I want us to talk about with Docker, which nobody posted an issue about, but I strongly suspect people will run into this problem. And that's something I don't think got to talking about on Friday, but it's the type of volume that the DB container is using. So I'm just gonna switch my screens to be side by side here for a second so that we can see the DB and the web service at the same time. We talked about the web service using the volume where you specify a path to the left of a colon. And I know this is a path to the left of the colon because it starts with a dot over here. So this is a path to the left of the colon. Down here in this volume, this is what's called a named volume. And to the left of the colon over here, this is a name and not a path. I know it's a name because there's no dot in front of it. So this is not a path, it is a name. And down here under volumes, it specifically says Postgres data down here. And with a named volume, this is a volume that the data is not going to be stored on your own folder, but Docker is going to manage this for you automatically. In production instances, all of your volumes should be these named volumes because Docker will automatically move the volumes to an appropriate server to have access to. If you're using this type of volume with the path, then you can only have your service running on the Lambda server and nowhere else. But with this type of volume, you could deploy it to, say, AWS and everything would work fine. The key here is that if we make a change to this table, well, let's see, we haven't talked about SQL, so I won't actually make the change here. But the source code is making changes to this table at various times in the tutorial, and if ever it behaves like or behaves in a way that you don't think it should, then one thing that you can do is you can reset the volume so that it actually deletes all that data and resets it from scratch. The volumes are stored in this separate location, and so bringing down Docker compose down, bringing down your services does not delete the data in the volume. Again, that's the main reason for having volumes is so that when you bring it down, you don't delete the data. And especially for a database, you don't want to delete the database every time you stop and restart your service. So databases are always inside of a volume. And here, even though I brought down my services, you can see there's nothing running down here. The volume still exists and it's still storing that data. So if I were to re-bring up my service, Docker compose up again, it would stay with the same data that it had. If you want to actually delete the data and restart over from scratch, then Docker volume rm, then the name of the volume will delete the volume. And now when you restart the web service, it'll actually recreate the database from scratch here. So if you're having weird issues with your database, it's not doing what you think it should, a likely fix for that is resetting the volume here and recreating the database from scratch. Any questions about anything about the Flask on Docker stuff? Yes. Question is, here in the environment right here, I have these passwords here. So recall that the docker compose.yaml is just for development purposes, and it's the docker compose.production.yaml that is the production one. The production one with the production database information is what you can't provide. If the development database is less important. It's the production information that you can't provide. Question is how to generate a random key for that. I don't remember the incantation off the top of my head, so it's fine just to smash your keyboard or to Google it, and there's some, it'll just be a one-line thing that'll output a bunch of randomness. At least with how mine is set up right here, the only file with sensitive information is this .env.prod.db. So that's the only one that I'm not pushing to GitHub. Everything else gets pushed to GitHub. So the only thing that I'm not pushing is the password itself. All of the configuration information is being pushed to GitHub. Last chance for questions. It's not last chance. I'll be happy to answer more questions today in office hours or tomorrow in office hours. But last chance right now for questions. Okay, so we're going to switch gears. Enough of Docker. Focus on SQL here. I want to start for us with, well, I was going to start with the more technical stuff. I think we had a pretty technical week last week, so let's start at the high level stuff, and then we'll get more technical later. The idea, again, Postgres, this database system that we've been working with, is an example of what's called an RDBMS. That stands for Relational Database Management Systems. And in general, it doesn't matter what your problem is, a database and an RDBMS in particular is always going to be a solution. And every web page that does anything moderately interesting has a RDBMS as its backend store of all the interesting data. So this first Dilbert comment here is just, they're not, the engineers over here aren't even listening to whatever the pointy-haired boss is saying. They just recommend building a database right off the bat, and we like databases. That's always the engineer's solution for every problem. We're going to talk a lot about the special features of databases, how they basically make everything guaranteed to be asymptotically fast and correct, guaranteed not to lose your data. So hopefully by the end of the next, I don't know, 7 or 8 weeks or so, you will also be like Dilbert and answer database for everything. The particular databases we're using, RDBMSs, will be using the SQL language for accessing the database. SQL is generally pronounced as SQL and not as SQL. I have a fairly strong statement here, but that SQL is a shibboleth for not being a databases person. There are lots of people who pronounce it SQL, but I can get a pretty good sense of like who it is I'm talking to and how technical they are in their database knowledge based on just their pronunciation of this word. So here, the joke in this comic here, I think we should build an SQL database. We know that the pointy-haired boss over here pronounces it SQL because it's an SQL, not a SQL. And so that's why Dilbert here is saying, uh-oh. So SQL, reason it's pronounced SQL is originally SQL like this, but for trademark reasons, shortened to SQL. And if you want the official explanation of all that, here's the ANSI history of the SQL language. One of the things that we're going to be seeing later today and throughout the week is that SQL, because it was invented in the 70s, just like the POSIX shell, it's going to have a lot of weird warts in it for backwards compatibility. That back in the 70s, people just didn't know how to write good programming languages. And so in some sense, we'll be stuck with those design decisions. But overall, SQL is it's pretty powerful, I guess, in the same way that the shell is. High level idea, comparing to other languages. So imperative languages, so things like Python or other languages you might have used, those specify how to compute what you want to compute. And then a declarative language, SQL is an example of a declarative language. We're going to specify what we want to compute instead of how. And then something called a compiler will convert the what into a how for us. And this is very nice because something that it would be like hundreds of lines of Python code, we can specify in just a single line of SQL code, and we'll be guaranteed also to get asymptotic efficiency. Whatever the best possible big O notation is for that problem, we will get that with our database. One of the reasons for this Twitter assignment that you're working on, you'll see that there's going to be, you don't have to write too much Python code, but there's a lot of Python code going into it. In like 4 or 5 weeks, we'll see how to do all of that in just a single line of SQL. And so that'll help motivate the power of SQL for you. In the Flask homework, rather than writing SQL, so they're interacting with a database, but they're not actually writing any SQL. They're using something called an ORM, Object Relational Mapper. And these are moderately popular among sort of like medium tier websites. The most popular one that uses SQL Alchemy is Reddit. They use SQL Alchemy for all their internal database access. And again, SQL Alchemy is what the Flask on Docker assignment is using. And these things are really easy to get started with, but especially once we start talking about how do you make things fast, you won't be able to do that with an ORM. And so Twitter, they originally started using a system called Ruby on Rails, which is a famous ORM. It's probably the most famous one, but they were unable to scale. And so at some point they switched to Java and writing their SQL directly by hand in order to get this good performance. So one of the standard sort of lessons that people take away, and if you want to more details about that, is that if you really care about performance, you have to actually learn to write SQL. A lot of companies try to abstract that away, but it just doesn't work. And if you really need high performance. So we're going to be not using any of these ORMs in this class and actually focusing on SQL. This is all related to something, these RDBMSs. Anytime you see the word RDBMS or this phrase relational, this always means that SQL is the underlying technology that's accessing them. There are other types of databases, for example, NoSQL databases. These are the most popular NoSQL databases these days. Once we get into the how to make things fast portion of the course, we'll see why these are not as good as the SQL databases, at least in my opinion. They basically sacrifice a lot of correctness guarantees in order to make things a little bit scalable. And then there's another thing called graph databases, and this is actually something that Wikipedia uses under the hood. Uses a language called Sparkle instead of SQL, but we won't talk about that. Any questions so far? All high-level stuff? Okay. Maybe we'll pause the high-level things here and start getting into technical things that you'll need to know directly for the homework assignments. So the homework assignment is posted in this folder, this Pagilla homework right here. And if you click that, it'll take you to this repository right here. And we're going to, I'm going to switch over to the terminal here in a second, and we'll see just how to get started interacting with this repository and getting a sense of what you'll need to do for this homework assignment. You'll notice down here that there is this test cases, passing, failing thing down here. So this is going to be like a callback to the very first of our homework assignments, that the grading for this homework assignment is going to be very clear cut. There's going to be clear test cases, and you'll either pass them or fail them, and you know exactly what your grade is when you submit based on how many test cases you're passing. I don't expect anybody to have weird Docker issues or anything like that with this problem. It's just going to be there's a handful of SQL test cases, and if you can write the correct SQL, then the test cases will pass. In order to get access to this repository, there's some weird instructions. So I'm going to walk through what they are over here in the terminal. Let's reset both of these. I'm going to go into a temp folder for both of these, and let's delete that. There we go. Oops, reset. So here I'm just in a temporary folder because I already have a Pagilla homework folder that I don't want to overwrite. It's very common when I'm working. This is sort of my typical structure of my home folder. Put permanent projects in this proj folder, anything that I can delete at any time. If I want to say make space for things, I put in a temp folder like this. And again, TMP is the most popular name for temporary folders because it's short, kind of sounds like temporary, and it has no vowels. And Unix people hate vowels and they love short things, especially things 3 letters long. I'm going to run git clone https://github.com. Mike is Bicky spelling my name correctly /Pagilla homework, and that clones everything. Well, come into the Pagilla homework folder like this. You run ls, and there's all the stuff down here. If I try to run Docker Compose though, so Docker Compose, say build, we'll have to do that before bringing things up. We will get an error message down here. And this error message is to be expected. And what it says down here is that it was trying to copy this file right here to this location. Again, when you're copying, the thing on the left is the thing that's closest to you. So this is the thing on the Lambda server. And the thing on the right is the thing that's farthest away from you. This is the thing inside of the Docker container it's trying to build. And the Docker container is going to contain the Postgres database that we're going to be working with here. The fundamental problem for this copy failing is that this file right here does not exist. If I type ls and ls Pagilla like this, we can see that there is nothing inside of the Pagilla folder. ls Pagilla, there's nothing in this Pagilla folder. If I come back to the GitHub webpage, you can see right here that this Pagilla folder has this weird like @ symbol next to it. It's not like an ordinary folder. And if I were to, so if I click on an ordinary folder, you can see that I'm staying inside the Pagilla homework repository. But if I click on this folder right here, it's taking me to an entirely new repository owned by, in this case, somebody totally different, not owned by me. And this hash right here, it indicates that this is what's called a GitHub submodule. It means that the contents of this folder are not actually contained in this repository, but contained in an entirely separate repository. And this hash right here is the commit hash that corresponds to the data that we want for our repository. In order to actually get access to this information, yeah, this is the right spot. There's so in order to access submodules, we need to run 2 extra commands that will get us access to that information. These commands are listed down here in the README file at some point. Here we go, here they are. So after cloning, you cd into it, and then it's git submodule init and git submodule updates. Git submodule init just tells Git to start being aware that there are these submodules that it might need to gather information from. And then git submodule update is like running git clone, actually gathering that information into those folders. Submodules are extremely common in large programming projects because they allow you to have well, I guess why they're common, maybe not super important, complicated explanation, but they're just very common in large programming projects. After I run the git submodule init and git submodule update, now when I run ls Pagilla like this, I have the contents of those files here, and now I can actually run the docker compose up command, or sorry, the docker compose build command, and it will actually be able to find that file and copy it over, and everything builds. So previously it was this line right here that was breaking because this file did not exist, because I had not gathered the information from the submodules. But now that I have gathered the information from the submodules, the project builds correctly. Any questions at this point? You're all going to have to go through these steps in order to actually complete the assignment. Okay. If I run Docker PS, then you can see there are no containers running. So let's do Docker compose up. We'll send it to the background -d like that. Docker PS did in fact run it, everything. And now if I do Docker compose exec, and my service name here is PG pSQL, that will connect me to the database. And now if I do, for example, \d, that will list all the relations that I have access to inside this database. When working with this database, there's a very famous database in the Postgres world. And this image up here is going to be something that you'll be referencing a lot to figure out exactly what the structure of this database is. Let me try to zoom in here a bit. There we go. Each one of these boxes represents a table or a relation in the database. And then the top box, sort of this title, that's the name of the relation. And then each one of these words or entries inside the box, that's one of the columns of that relation. The meaning of this database, the high-level idea is that this is like if we were running a DVD rental business, so something like Blockbuster before it went out of business, then this would be the sort of database that they would have on their back end. Netflix's database actually looks just like this for their the portion of their service that sends out DVDs to people, but then they also have a bunch of additional stuff added on top of this for their streaming services. Let's take a look at one of these. So this film table right here, for example. And if I do \d, we can see that somewhere inside of here, there's a film relation. Again, the \d lists all of the tables or all the relations. Over here, this is the type of the relation. So a table is the simplest type of relation. That's what we're going to start off talking about. And the right way to think of one of these tables is just like a single Excel spreadsheet that we can put information inside of. This output down here that I'm, when I do \d, this is called the pager environment in my database. Let me write that out. \d takes you to the pager environment. And the pager environment has a bunch of hotkeys, just like Vim does. So like /, for example, lets us search. And so if I wanted to find information about the film table, I can do /film like this, and it will take me to the place about film. And here's the table information. I'll press Q to get out of that. And now we can run our basic SQL commands to explore this film table a little bit. The first of those SQL commands that we'll take a look at is the select command. Select star from actor like this. When you have the select command, what comes to the right of the select command is a list of all of the columns that you're interested in. The star behaves like the glob in the bash terminal. So here when I say star, this pattern matches to all the possible columns from this actor table. When I hit enter like this, here's our sort of Excel spreadsheet looking thing. Up here at the top, we have our column names, last update, last name, first name, and actor ID. So not from actor, we were looking at film like this. And okay, let's go back to actor. That was a little bit complicated. So first name, last update. If we come back over to our table over here, where did actor go? Right here, we can see there's 4 different entries inside of this actor table: actor ID, first name, last update, and all 4 of those correspond to the 4 columns over here. The first name, last update, these are all what we call semantic columns. Semantic means that you'll have to basically use your best judgment to understand exactly what's going on with them, that there's no the meaning of these columns is domain specific. Domain specific. And so in the actor table, we can guess that that this corresponds to the first name of an actor, this corresponds to a last name of an actor, and this corresponds to the time that this information was last updated in the database. You'll have to, at some points, just kind of use your best judgment, though, to figure out what's going on here. In this case, though, each row corresponds to an individual actor. So Penelope Guinness is the first row, then Nick Wahlberg, and so on. Any questions so far? Yes. Question for, so I'll just review all of the commands that I've typed in. In order to actually connect to pSQL, it's Docker compose exec the database service name, then pSQL like this will connect me to the database. \d lists all of the relations that I have. Q exits the pager environment, and then select star from relation name gives me the actual like Excel spreadsheet of all the information inside of that relation. Did one of those things answer your question?
What happens if the Docker
I don't know what you mean, Docker compose not letting you answer. If you run this command and it doesn't bring up a prompt, then you somehow have an error, and you'll want to look at the logs to figure out what the error message is and try to fix that. The most probable error of pSQL not working is that you the build failed, and that most likely cause of the build failing is the submodules not being initialized before running the build command. But you'll definitely have to be able to get this working into an interactive environment in order to be able to solve the homework problems. I can take a look at that specifically later after class. So this is an interactive environment for typing in SQL commands and seeing what we're going to get as the output. And for the purposes of the homework assignment, the interactive environment is useful for debugging, but you'll also need to be editing files and running those files. If we type ls right here, we can see that there are two files here besides, or sorry, two folders besides the Pagilla folder. Again, the Pagilla was our submodule that contained the data that we're going to be working with. And the expected and the SQL folders here, these are like a standard part of every Postgres project. SQL and expected are standard folders in every Postgres project, If we look inside the SQL folder, ls SQL, you can see there's a bunch of files that end in .sql. I will often say .sql to emphasize that I'm talking about the individual letters here. This doesn't have any semantic content to it. These files could be named whatever we want, but each one of these files, the semantics of it is that it has the SQL commands inside of it. Each one of these, for your assignment, each one of these is an individual SQL command that you'll have to enter in here to solve the particular problem. If we open up this first one, do vim sql/o1.sql, we can see there's a comment up here at the top where it tells us in English what we're trying to achieve. And then you'll have to, down here, enter your SQL commands here. In SQL, there's two types of comments. This is called a C-style comment with a /* like this. The more common type of comments, though, for SQL is a --. So --, this is a one-line comment. This is part of this, the SQL standard. Every SQL database implements this. This is not as universal, but 99% of databases will implement this format up here. In order to know if your results are correct, if your code is correct, the expected folder up here, expected/o1.out, contains what the output of the SQL command is. And when the test cases get run, it's going to run your SQL command, compare it to this known good output. And if it matches exactly letter for letter, then you'll get, it'll pass that test case. But if there's not, or if there's a problem with it, then it won't pass the test case. In order to run the test cases, the command is docker compose exec pg. So we're running it inside of the Postgres environment, and then this check answers.sh script right here, and /check answers like that. And here you can see that it's we're getting a lot of failures and a lot of error messages throughout here. As you work on these problems and implement them, these fails will change to passes. And if all of these say pass, then that green or that red badge on the README file will turn green and you'll get full credit. Question is, does each file contain just one problem? And the answer is yes. Each file contains exactly one problem. If we look at the files themselves, let's do ls SQL to look at it. They're arranged from easiest to hardest. So 01.SQL will just actually do this one in class here in a minute. Is the easiest, and then 17.SQL over here is the hardest. Some of these do like this. Problem number 2 has sort of 2 variations of it: 02.SQL and 02.function. It's basically the same problem. You'll just have to implement things in a slightly different way, which we'll talk about probably on Wednesday. But each one of these, yeah, you should think about it as one problem. There's a total of 20 of these SQL files, so 20 problems that you'll have to solve for this assignment. Yes. Question is, what's the command to run the test cases? This is the command down here: docker compose exec pg./check answers. And all of these commands, there's summaries of them in the README file on the Pagilla homework. And so here is that command again. Okay, we'll go through and implement this first problem here in just a second. Before I do that, though, I'm going to head back out of this Postgres, sorry, out of this Pagilla homework folder back into the topic 4 folder. And I want to scroll down to what did I want to scroll down to? Oh, yes. This section down here, what you must know for the homework midterm. We'll do an overall summary of this. Again, after talking about the details, but here are your references that if you want to, if for whatever reason was something that we don't cover in class, or that we do cover in class doesn't fully make sense and you want a written reference, this postgrestutorial.com is what we'll be using as our sort of textbook for this section. For this first homework assignment, the specific commands that you'll need to know are the select and the join commands. And so it's basically the first 4 sections of this tutorial up here. Okay. Back over here, how can we go about actually working through and solving one of these problems? In the top window up here, I'm going to open up, so SQL/o1.SQL. Again, open up the problem statement itself. This is where we will be typing in our command when we think we are ready to evaluate it. I'm also going to use the :tab E and open up my expected 01.sql.out so that I'll be able to just go back and forth like this between what is the code that I currently have right here on 01.sql and what is the output that I'm trying to get over here on 01.out. You'll notice now that there's actually one more folder down here, this results folder. Previously, there was only SQL and expected. This results folder got created when you ran the checkanswers.sql, and results actually shows you what is the contents of the command that, or what did you actually get. If I come over here, :tab E results /01.out. Currently, we don't have any SQL commands in our 01.sql file, so this the contents over here is empty. But as I'm working on these problems, as I'm working on problem 1, I'll have all 3 of these things open so that I can reference all 3 of them to help me in my debugging process. Any questions about my setup right now? Yes. Question is, what's the command to switch tabs? The :tab E opens. GT, the mnemonic is go tab. GT goes to the right. G shift T goes to the left. In general, lowercase in Vim goes forward, and uppercase things go backwards. So here it's saying display the first and last name of each actor in a single column in uppercase letters. Down here, I'm going to re-enter my pSQL environment. Just Control-R pSQL brings back my command down here. And down here, I'll run my interactive SQL commands to get me a better sense of what I'm going to need to do for this problem. The \D by itself lists all the tables, \D, and then just the table name like this lists the detailed information just about that individual table. So it's telling me here are the 4 columns right here of that table, and here's the different types of information about those columns. We want to display the first and last name of each actor in a single column in uppercase letters. So if I do select star from actor like this, this is in fact displaying the first and last name of each actor, but it's also giving me a bunch of other information. It's giving me this like last update, the actor ID, and it's not all in one column. So this is not yet what we need to do. Closer is something like first name, comma, last name like this. Now we have just the first and last name of each actor, but it's in 2 separate columns rather than a single column. The comma operator in SQL, when you have it, this area is called the column list to the right of the select. This is the list of all the columns that will be in your output table. We have first name and last name right here, corresponding to first name and last name down here, separated by the comma. And yeah, so this is called the column list down here. I'm going to take a look at what my expected output is over here. And here you can see that it is in fact just one column, and the first and last names have been combined together. In order to combine this information together, we'll somehow have to add it together like this. One of the warts about SQL is that the plus operator only works on numbers. Plus only works on numbers and not on text. In SQL, text is the type for strings, So it's, I'll use text and string probably interchangeably throughout the course, but text is the most formally correct thing. And if you want to actually concatenate strings together, concatenate text together, it's a double vertical bar like this. So it looks like the OR operator from Bash, but that is string concatenation in SQL. So that is string concatenation in SQL. We're gonna all of the familiar terminal niceties that you're used to from the shell work inside of Postgres. So inside of pSQL, so the up arrow all works. Control R for a reverse history search works. I'll press Control R. I'm just trying to get back to this command right here and rerun it. Type in select, and there we go. And if we compare this output down here to this output up here, we can see that like this is definitely not correct. It's not matching exactly the same because here I'm just putting first names next to last names without a space in between them. If I want to actually add a space between them, then we actually have to specify a space like that. And now it puts the space between them. Another oddity of SQL is that single quotes and double quotes have very, very different meanings from each other. And if we were to use, say, double quotation marks around the space like this, we'll get an error that this is, anytime you use double quotation marks means the thing inside is a column or relation name, and single quotation marks means the thing inside is a value. So it's not a name, it's a value. But yeah, come back to this command. Single quotation marks is what we want. If I put double quotation marks around something like last name like this, we'll get the exact same result over here. You can see it's getting the last name values over here. If I put double quotation marks here around last name, that gives me the exact same contents as single quotation mark, sorry, as no quotation marks around last name. If I were to redo this with single quotation marks around the last name like this, then it literally puts the word last name everywhere. You're not going to ever have in this class like reading sort of questions like you have about the bash scripts. It's all going to be just writing, and so you'll always have the access to pSQL here when you're working on things. For your midterm exam, you'll have access to pSQL to actually type in your problems and make sure they are correct, doing what you want. I won't test you on like the single versus double quotation mark, but there'll be times when you'll have to use one or the other and know which one to use correctly. Go ahead and hit enter. Another thing about SQL is that the commands must be terminated by a semicolon. So I could type select first name or last name from actor, and then it's only when I hit the semicolon down here that it actually executes that command. SQL is also case insensitive outside of quotation marks. SQL is case insensitive outside of quotation marks. And so it's very common. The standard formatting is that the actual SQL commands are in uppercase and column names and table names are in lowercase. So select first name, space, or last name from actor. This would be the most sort of standard formatting for this particular command. But for the purposes of this class, you're not going to be judged on the formatting here of any of these commands. There is no linter for the SQL code. It's just going to run it and check to see does it get the correct output. Okay, so we're almost, I don't know, we're making a little bit of progress towards getting this this expected output out here. But if we come back to the answer down here, it says display the first and last name of each actor in a single column in uppercase letters. But then it also says that the results should be sorted alphabetically, and we're not sorting alphabetically right now, but up here it is sorted alphabetically. So how do we sort alphabetically? In SQL, anytime you want to sort something, the command is order by. So down here, order by. And then how are we going to order things? We have to specify, down here, how we're going to order them. So we'll try something like first name, like that, order by first name. And now things are starting to look a little bit more like they look up here. Down here, when I said order by first name, it's going to sort things by the first name, and then, but it's not going to care about the last name at all. So when I rerun this command, we have Adam Hopper and then Adam Grant, but up here we have Adam Grant and then Adam Hopper. So we don't want to just order by the first name. We want to break ties by looking at the last name like this. Order by first name, comma, last name. And now we have Adam Grant and Adam Hopper like this. The last name in the correct order. So now, I don't know, this is starting to look very similar to this stuff up here to me. So I'm going to actually test my code with the test cases now that I think I have something that might work. And we'll see how to interpret the output of the test cases a little bit better. Before I do that, any questions about just what's going on in this SQL command right here? How did I enter the shell? What do you mean by that? So in order to get into pSQL, it's Docker Compose exec pg right here, the name of the database server, and then the name of the command that we're running on the database server. pSQL is the command that lets us type directly into the database and use it interactively. And this is my suggested answer to the first SQL problem so far. Good question. Any other questions so far? Okay, up here in my SQL code, I will go ahead and copy and paste this proposed solution up here, and so that we can run it and see whether it will work or not. I'll escape :W to save that. And you'll notice that in the top up here, in the top, I'm only connected to the Lambda server. I'm not actually inside of the container right now. The change that I've made to this file, though, will be propagated over to the container, because if we look in my Docker Compose file, I have a volume that maps my current folder to this folder on the Postgres container. And so every change that I make, I only have to make it on the Lambda server, and the volume over here will take care of the fact that the container will be able to see and access those changes. Let's come down here. Let's leave the pSQL environment, and I'm going to rerun my check answers command. I'll press Control-R to go back to the check answers command like this and hit enter. And it's going to run a bunch of stuff. We'll scroll up to the part where it's talking about the very first problem. And here we can see the SQL 01.SQL fail. So it's not giving me the correct answer. In order to take a look at why it's not giving me the correct answer, again, I'm going to look at the results file, ls results. All of these are the output of actually running the contents of the SQL folder. The results is what we actually get from running the stuff in here. The expected is what we're supposed to get from running the stuff in here. And so we need to compare the results to the expected and see how are they different. Here, you notice that in Vim, I still have my results file open up here, but it doesn't contain anything inside of it. Anytime a file is modified in some way by the computer, Vim does not automatically update its representation of the file. And in order to update that, you have to tell Vim to reload the file. The way to do that is the :E command. E stands for edit, so we want to re-edit the file. :E will reload the file. And now this information will look hopefully a little bit like the information from the command that we were running in pSQL. And now we have to compare the results over here to the expected and see what is different about them that's causing the results to be different than the expected. And so I'll just go back and forth between my using G-Shift-T to get a quick visual sense about what's different between the two. And you can see that a lot of the things are the same, but the first thing that's jumping out to me as being different is this top line up here that I have on my results over here, question mark, column, question mark. And on my expected over here, I have the actual actor space name over here. when we're doing the comparison between the results and the expected, like every character of the output has to match literally. There's no interpretation of this going on. It's literally just checking to see, are the bits in the two files exactly equal to each other. And so in order for these two things to be the same and pass, not only do I have to get the actual contents of the query down here correct, I have to have the column names of the query up here correct. In order to specify a column name inside of SQL, the command is as, and then inside of double quotation marks, what you want the column name to be. So in this case, we want it to be called actor name like this. And at this point, this line is getting a little bit long for my taste. So I'm going to move things down like this. And it's very common to have your column list on one line next to the select statement, and then from actor all on its own separate line, and then any order by clauses or other things on its own line down here at the end. Here, so we were talking about the difference between double quotation marks and single quotation marks earlier. This is the name of a column over here. It is not the name of a value. This is the name of a value over here. So things that are names of values go in single quotation marks. Things that are name of columns go in double quotation marks. If you have no spaces in your column name, you do not need double quotation marks. You only need the double quotation marks to indicate that there's a space right here. Because there's a space in the column name, we have to use the double quotation marks. And if I do this, I'll colon W save that, come down here, up arrow back to my check answers command, reruns all those tests, come back over here, colon E to reload that. And now we have that actor name is actor name up here, and those two things match, actor name and actor name. Any questions about this or what I've done so far? Let's see. We have about 1 minute left, and you can see here that if I just bounce back and forth between these two files, that the contents still aren't exactly the same, that things are ordered a little bit differently. And this is going to be an important and subtle point that I want us to spend a lot of time talking about. So we will save that discussion for next class period and pause here for today. Again, we'll have the quiz on Wednesday about the glob. Definitely recommend that you by Wednesday have access to Pagilla and that you can run it and get into the interactive P-SQL environment so that you'll be able to follow along with the things that we're going to do. Things are going to get very weird very quickly here with SQL. At least this weird will be like conceptual weird though, and not like ghosts of the computer doing weird things weird. But so definitely recommend you be able to follow along on Wednesday in class. That's it for today though, and I will see you all on Wednesday.